Some time ago, Kubernetes had two main challenges when you set it up on your machines. On one hand, networking, and on the other, storage. Both have evolved a lot, but today I'm here to tell you about a great alternative to make the second one a bit easier for you. But first, let me tell you a little something. Today I'm here to talk to you about JuiceFS. It's a file system that's capable of storing data in a C3 bucket. The metadata in a database can be integrated with Kubernetes because it has a CCI controller and requires very little maintenance. But if you're new to this, you might be wondering, Hache, what on earth is a CCI controller? So before we move on to talking about JuiceFS, let's take a look at a bit of Kubernetes history. Don't skip this part because it sparked a lot of beef between Google and Amazon. As I said, storage in Kubernetes is one of the biggest challenges you face when setting up a cluster. In the cloud, this is usually pretty much taken care of for you. So what exactly is the big challenge with Kubernetes? Well, you see, workloads can move from one machine to another. When you kill a pod, sometimes that pod ends up on a different node. If it had persistent data and stored data on that node, that data needs to be mounted on the new node so the pod can access it again. Otherwise, it would have to start from scratch. Kubernetes does this automatically, and it's one of the many conveniences the orchestrator provides. But it hasn't all been a bed of roses. Well, roses, yes, but with plenty of thorns all over until we reach the wonderful world of Narnia where everything magically works now. In Kubernetes, a mechanism called CSI is responsible for volume operations and it works separately. But it wasn't always like this. In the past, the Kubernetes project supported all cloud providers by itself. This meant that the code needed for volumes from providers like Amazon to work was inside Kubernetes' own codebase, and the same was true for more than 40 other providers. When someone from Amazon wanted to make an improvement or fix something in their volume system, they had to merge the code into the Kubernetes project itself. And to get it all the way through, it had to pass the tests for all the other providers. This way, it prevented one provider from breaking another provider. Now you can imagine where the drama is going, right? You must be freaking out right now, and you're right, this ended up being unsustainable. How did Kubernetes fix it? By introducing an interface for storage. What? What is an interface? Huh? Let me explain it to you. An interface is a specification, kind of like a black box with wires hanging out, where you only care about the wires and what you can do with them, but not what happens inside the box. You care about the wires and what you can do with them, but not about what happens inside the box. Kubernetes has one of these interfaces for storage, and that's what's called CSI. The wires that go in and out of the box have to be the same for all providers, because those are the wires Kubernetes uses to make requests. Also, the things Kubernetes can request and the things it gets in return are standardized. That simple idea made it possible to move all the storage providers out of the Kubernetes code and keep that code as clean as possible. In return, providers who wanted to interact with Kubernetes volumes would have to implement what happens inside the box. What happens inside the box is called the CSI controller. And here comes the juicy part, the interesting part, the important part. Thanks to that, it became possible to create a controller for any file system, not just for the cloud. And at that moment, someone thought, what if I make a file system that uses a bucket as storage? Buckets are cheap and require no maintenance. And that's how JuiceFS was born. JuiceFS is a file system that stores data in chunks in an S3 bucket and the metadata in a database. For the database, you have many options to choose from, like Redis, Postgres, etcd. Basically, there are plenty of choices, but use the one you know how to maintain best. Remember that metadata is important. Without it, you can't recover the data. Additionally, the project maintains a CSI controller for Kubernetes, which allows you to mount your file system on standalone machines in your favorite orchestrator or even in both places at the same time. Well, you might be wondering what advantages JuiceFS has. For me, there are three main ones. The first is that the storage is virtually infinite. We're talking about a bucket, so you'll never have to worry again about a volume being too small, having to resize, or having to move data. The second and very important is that JuiceFS is POSIX compatible. This means that your applications can perform the same operations they were doing on files, including locking, which normally isn't possible when mounting a bucket directly. What's more, it's a file system that you can mount both on your standalone machines and in Kubernetes at the same time. So, you can create hybrid architectures or migrate to Kubernetes very easily because you can share data in real time. So, unlimited storage, POSIX compatible, and mountable everywhere. So if you like what you're hearing, hold on, because we're about to get our greasy hands on fine. But first, look at me, subscribe. subscribe so the channel can grow on YouTube, hit the button. Go on, do it. Now let's continue. By the way, don't worry about the manifest or the commands you'll see on screen because I've explained everything in the channel's repository. I'll leave the link below in the description box. The first thing we need is a bucket, which is where the data will be stored. You can create it with your favorite provider. There are several that are relatively cheap, but I recommend two things. First, the provider. My favorite is Cloudflare R2 because they don't charge you for outbound traffic. And this is super important for having predictable bills at the end of the month without the hidden cost of Amazon or GCP. The second thing I'm going to recommend is that wherever you do it, create the bucket close to in the same region as your workloads, because that way latency will be less of an issue. As you can see on the screen, I've already created my bucket in Cloudflare for this video. The second thing we need is a database. If you want your cloud provider to manage that database for you, use their database service. And actually, this is the most convenient option. For this video, I'm going to set up a small Redis cluster inside the Kubernetes cluster. I'm going to use the Bitnami Helm chart with the values you see on screen. The only thing to keep in mind is that I've already created a secret in Kubernetes that contains a random password for the Redis admin user. That's the reference you're seeing highlighted on screen. No matter where you set it up, remember that this database needs to be reachable from every single point where you want to use your JuiceFS later. Expose it only to your internal network, secure it, and remember, never, ever, ever expose a database to the internet. Nice. Now that we have the storage ready, it's time to format our file system. This is an operation you only need to do once, so it's not worth automating it. Since we're in the 21st century, we're going to spin up a Docker container that runs the command you're seeing on screen using your bucket and database credentials. Uh-oh, I can see the credentials. I know dealing, but by the time you watch this video, I'll have already deleted everything. Since we're in the 21st century, we're going to spin up a Docker container to do it for us by running the command you see on screen. There, you enter your own bucket and database credentials and run it. When you run it, if the log output looks similar to what you're seeing on screen, it means you were successful. Now you have a functional feature system. Easy, right? Now all that's left is to use it. Let's install the CCI controller for Kubernetes from JuiceFS on those clusters where we want to create volumes with this. The first step is to create a Kubernetes secret with the credentials that JuiceFS will use in that cluster. Credential provisioning should be automated with tools like external secrets. If you don't know what I'm talking about, just so you know, I have a video on the channel. I'll leave the link up here. For this video, we're going to do it ourselves with our greasy hands, which will leave you stained with dishonor, but at least you'll learn something new. Run the command you see on the screen to create that secret, and voila, we've now created the secret in Kubernetes. Now let's install the JuiceFS controller. We're going to deploy it with Helm. I've left you some parameters with comments explaining what they're for. Some of these parameters affect the later performance of JuiceFS, so make sure to read them. Almost all the basics are down below where the storage class is created. To start, we reference the Kubernetes secret where we have the credentials. Each Kubernetes volume will be stored inside a directory in JuiceFS. So, I'm going to give it a recognizable naming pattern for the future. We're also giving the storage class a name. We deploy on Kubernetes. Another success. Here we have our JuiceFS CCI controller started and our storage class created. Let's spin up a workload. have two replicas of Nginx with a UISFS volume mounted in a directory. Let's go inside. What should happen is that when we write to this directory, we should see changes in the bucket. And another thing that should happen is that if we kill the pods and the recreated ones access this same directory, the information is properly saved. As you can see, when writing content to a file inside that volume, data has been uploaded to the bucket. Let's check the second premise. And indeed, after restarting the pods, the information is still here because it was in the bucket. So nice. Nice. As you can see, UIFS is ideal for having storage that's easy to maintain across all your types of workloads, from standalone machines to Kubernetes clusters, all using nothing more than a bucket and a database. It's scalable and simple. So if you like this video, let me know down below in the comment section. And if you didn't like it, share it to annoy more people. Subscribe, give it a like, and do all those things that help the channel grow a bit. With that, I'll say goodbye. See you in the next video. And blow up. Firehill Direct.